Hi, everyone. On behalf of Maritime Reporter and Marine News, we'd like to thank you for attending our webinar with Faro, presented by Daryl Johnson, about applying 3D laser scanning to the marine industry. If you have any questions during the presentation, please use your chat feature on the right-hand side of your screen there, and we'll be happy to answer them. Without any further hesitation, let me pass this over to our presenter, Daryl Johnson from Summit Engineering.
Okay, can everybody hear me?
Yep, you sound good.
Okay, and they can see my screen?
Yep.
So we're ready to start, and I appreciate everybody who was able to attend. And I want to let you know that typically when I give these types of presentations, I appreciate questions during the presentation rather than waiting till the end. So if you want to send in a question via chat, please feel free to do that. Mark will be cutting in with those where he sees them appropriate. So with no further ado, let's get started. And we've been involved in scanning for quite a while, but we've done it because we think there's real value in it. And so I want to start out with my first slide, introduce myself, Daryl Johnson. And then along with me is Norm Johnson, and yes, we are brothers. And we've been working on this together for quite a few years. And he's the brains, and I'm the mouthpiece. So that's how it works, and it works well. We have a good time doing it. So if you see, I've gone to our website before, you'll see these little clips. We haven't the money, so we've got to think. And it's our position that the looks like we're having a little problems with our video. So apparently the screen isn't quite maximized for everybody. So it is maximized for me. Let me make sure I'm showing the right screen. So sorry about that. How's that look? Is that better, Jerry?
There you go.
Okay. Is that better? Okay, sorry about that, folks. Good thing I didn't have anything embarrassing up on my non-showing screen. So now you should be able to see everything. And as things go, not everything always goes smoothly, but we usually can work through our issues. And I just want to express that we've gone through a lot of issues, and a lot of those that have come up are ones that have driven our development of our workflows and our interaction with Faro. And so it takes a problem to solve a problem, and we've got plenty of problems to work on, and we'll present those as well. So with that, I want to start with my first slide, and that is, if laser scanning is such a great technology, why has it been so difficult to get it into the marine industry? And we still struggle with that. And but let me give you a little brief history, our own history, and that is where we started and why in those days it just wasn't applicable to the marine industry. Back in 2001, my first scan job, this was the equipment we used. Total cost, $150,000. Total weight, 150 pounds at least. A lot of time, a lot of expertise required to make this work. A total station, a little small 40-degree window, and the data just wasn't very good. So if you were familiar with this system back in those days, you cannot possibly envision carrying this stuff around on a ship. So fast forward to 2004, you'll notice, go back and forth, nothing changed with the equipment really. There was some other equipment starting to be available, but for the most part, this is still the equipment, and cost and weight and everything, quality of data just wasn't there, still too big to carry around on a ship. 2006, things started to change a little bit. We got faster scanners. It took more data and did a full 360. This is just one of those. This happened to be the first one I ever bought. And there was also some other Leica products that were available, and this was a Leica scanner, but it was a rebranded ZNF scanner from Germany. But very fast, and for today, very good data. But you still needed a lot of targets. You still needed a survey to tie it together, and still difficult to run this on a ship.
Hey, Daryl?
Yes?
What kind of cards are those on the bottom?
You're talking about the targets?
Yeah.
Those targets are just numbered targets, and those are used with the survey. So the scanner would pick those targets up, And even back in those days, Leica's cyclone software would allow you to actually find those targets in the scan data, and then you would tie those together with a high precision survey done by, using the theodolite, and then that would piece or stitch together all the different scans and get them in the right geo-reference coordinates. Okay?
Great, thanks.
Good question. And some people still use targets, but when we upgraded to the Faro Photon from our LS880, the data was so good that we were now able to confidently move forward with cloud-to-cloud registration. So you see that we dropped the targets, we dropped the total station, and now we can pretty much do just about every job we do without survey or targets. I will talk a little bit about the use of targets in a future slide. In 2010, we were fortunate to have received the first Faro Focus 3D delivered to the U.S. And this actually is because we were scanning on ships. And if I go back a slide, that stuff was still pretty heavy, not real heavy, 35 pounds plus a tripod. The battery would be was separate, so you had to lug that around with a cable. But it was doable. We could get under the grates in the ships and down in the hull and all kinds of places that were difficult to get to, but we could do it. But it wasn't easy. So when I came back from one of these jobs, in fact the one that's featured here in the middle slide here, I contacted my Faro rep and I said, I need something a lot smaller than this, and if you don't do it, I'm going to go find one somewhere else. And he had no idea that this was in the works, but 6 months later, my sales rep called me up and says, we've got it. I said, I'll buy it. So I bought it, and I got it right away. Actually, we ordered it in October and had it for our first project, which wasn't a ship job, but we did carry on luggage, took it all the way to Mexico, and did our first scan job less than a week after I got the scanner. And we had taken a week to prove that it met our requirements. The data was as good as the Photon, and the scanner weighed 12 pounds. Like I said, easy to take with you. And that really revolutionized the scanning world, not just for us, but across the entire board for the 3D laser scanning. And I'm glad to see that competition is getting there. There's a lot more of this type of option out there, and that competition is just good for everybody. So then last October, Faro came out with an iSafe laser, which was critical. One of the first jobs I did this January required an iSafe laser, so it's a good thing that I purchased one for that job. So the range increased from 120 to 330 meters, and the noise is really the big deal. Much finer data, much nicer registrations, and we had great registrations already. So yeah, we got one too, and we really like this progress. Cost, very, very reasonable, under $60,000, and this is making it possible for people to actually get scanners. For example, what we try to push is for people to have a scanner on their ships or on their rig, so that if they want to go out and do a quick job that might cost $10,000 just to get a person out there with a scanner, they have a scanner. They just send the data, upload the data, and we can work with it. So I wanted to talk about our workflow, and this is something that this is not the only workflow. There's a lot of different ways people go about doing this, but this is the one that we settled on, and so I mentioned before that we've gotten rid of targets. There are still people using targets, and Faro actually they use targeted for their registration. They use targets and Sears. We do, however, use targets occasionally to tie them into the client's reference coordinates. But we're finding more and more that if we just ask the client, where they want us to tie it in, show us a feature like a bolt or a certain column or some piece of some reference material that they're already using in their projects, and that's what they want to call their certain coordinates, we can just tie that in as easily because it's already there. We just move our data to match it, and we're good to go. So we do our final registration using Leica Cyclone. I mentioned here we pre-align scans and throw scene. That really, we can do that in the field, and that helps us make sure everything is in in place, and we don't have holes in our data, good coverage. But we ultimately do our fine registration in like a cyclone. Just so you know, we haven't evaluated it yet, but Faro is just coming out with a beta version, their next version of their registration program, and so stay tuned for my next presentation. We might have some information on how that's working. But to date, we found like a cyclone to be the best that's out in the market, and we tried a few others. We did, as a side note, we did evaluate All Point Systems, and their registration we were quite impressed with. And then a couple months later, they were bought by Autodesk, and they became part of the ReCap group. So if you're familiar with ReCap, you've been looking at Autodesk and what they're doing with laser scanning. ReCap is, actually I show it here on the bottom of this slide. But they also have a registration feature, which is improving. And we've done a little beta testing with that and like it for smaller jobs, and I think ultimately they'll be where they need to be for the larger 70, 80, 100 scan jobs. But after registration, we've confirmed that we've got good registration, really tight closure on our data. We post-process the scans in our software, and once again, one of the things that we had to work through is there's a lot of noise in the data, and that's mixed pixels and different things. It uses mirrors for its to gather its data, and so when you have reflective surfaces that might have a double bounce in the data, you get that. And there's different things that we developed for filtering, and that filtering then helps tighten our registration and also gives cleaner data. We then move on to isolation, which I'll talk a little bit about that as we get into the rest of the presentation. And then feature extraction. This is where cylinder fits and plane fits and those different things. We have been doing our own, we used to call them basic model parts. We get a face of a flange for a tie-in. We get a center line of a pipe if you're going to tie into it, those types of things. Top of steel, critical piece. We would get those feature extractions, and then we'd give those to our modelers. And they would model in CAD programs such as Chip Constructor, which we don't use, but have worked with them, and they can take the data just fine. They're on the latest platform of Autodesk, and that's a critical piece. Plant 3D, which is our current 3D modeling program, obviously just straight AutoCAD. Rhino 3D, we use that mostly for surface modeling, like if we're going to do the whole of a ship and that type of thing. And then SolidWorks, we've had a few projects using SolidWorks, and it's more than compatible with all the different workflows that we use the 3D scan data in. So if I'm going too fast or you want to slow me down and ask some questions, feel free to do that. But as we move down to visualization is a big piece of the puzzle that many people have been working on to actually be able to see what's going on in 3D point cloud, and more importantly, to look at what's going on with any type of design work done in the point cloud. So now Autodesk ReCap, it's really coming on strong. It's got a lot of good showing. It's got some very good features, and I really appreciate the investment Autodesk has made in 3D point cloud data. Yes.
Hey Jerry, we just have someone needs a little clarification on what you mean by registration.
Okay. Okay. If you think about in the just regular pictures world, for the last several years, you've been able to take pictures, and you could actually take several pictures that were all just you shoot it, and then you move a little bit, shoot it, and a little bit, shoot it, and those would all be kind of have a long panoramic type look, but they were not lined up. Well, people came up with software that would allow the photos to be lined up, so it now looks like just one long photo as a panoramic. Registration is the same type of thing, only now it's in the 3D world where they line it up in 3 dimensions and they overlap that data. So for example, a pipe that you scan on one side and then you move the scanner to another location, scan from the other, it sees 2 different sides, but if you don't, if you get those in the right place geospatially, they will look, the pipe will be properly round like it is. So that registration is basically putting the scans together so that they line up with what they really, the real world. So does that answer your question?
I think so. Thanks.
Okay. So thank you for the question. So 3D Navisworks is currently the single biggest tool we use for visualization and sharing the data with clients and with construction crews and those, so all parties involved in the work. And it provides a free viewer, so you can do your entire project, and then when you're ready to give it out, you give them a 3D model. Now, with that said, I'll give you an example of the size of those models. We did a project. It was 7 stories. It was a boiler replacement, and the total size of the model without scan data was 17 megabytes. So it was a nice size model, not huge, but certainly not small. Well, however, when we added the scan data to it, it went from 17 megabytes to 1.7 gigabytes. The scan data is still a huge, and those were subsample data sets. The scan, still the single biggest thing that we have to resolve in working with scan data is just the sheer size of a high-resolution photo that's in 3D. So with that, let's get to the webinar topics, unless you got any questions before I leave that kind of introductory state. And we'll go through this. So today I want to talk about, kind of touch on this, safe, thorough, and accurate chip checks. Scan to plan, that's something we like to play around with words, so we made that one up. And along with that is replacing kind chip piping systems. So those are going to be kind of connected. And then new equipment installation, and finally, computer-based training in 3D models. And when we get to that, I'm hoping we can have a little dialogue. So let's get on with this. Safe, thorough, and accurate chip checks. So this is a drill deck of an offshore drill rig. This is actually a ship, so it needed to be checked. And the question is, laser scanning versus something else. How is laser scanning any safer than the other option? So the answer is that up to now, the way people would normally measure things would just be get to whatever you're measuring and get a tape measure on it. So ladders are not as safe as stable surface-based measurements, and scanners always have to be on a stable base. So that's the situation with that. So definitely we've found scanners, because they can reach where you can't access very easily, they would be considered safer. Okay, so, and then as far as thorough, how many measurements can you actually put in a notebook? And even when you do put it in a notebook, typically the ones I've seen are a lot of chicken scratch. So the designer has to come back and redo it so that somebody else can understand what's going on. And then they also usually draw a picture. And if they are really good, they draw one that looks a little 3D, and then they put their measurements on it. Well, with 3D scanner, you've got that. And you've got millions of points, billions of points actually for a large project. And then finally, tape measures are very accurate. In fact, if you had to compare the scanner to the tape measure itself, the tape measure is a little more accurate, but only as well as you can read it. It's the people that are the problem. And okay, in defense of the people, it's not so easy to use tape measures on a ship, and plumb bobs aren't any easier on a ship, especially if it's out in the ocean rocking. So, but these are the tools. These are the classic tools that people have used, and that's what 3D laser scanning is taking place with. Now, with that said, the tape measure and the plumb bob, they may only cost, $35 for good quality ones. However, the scanner is $60,000, so the tape measure and plumb bob have the advantage there. What they don't have is the advantage of being fast and thorough. So, the proper use of 3D laser scanning, as I said, provides safe, thorough, and accurate chip checks. Scanners placed on stable, safe surfaces such as deck, floor, grading, catwalk, scaffolding. We've also actually hung them out in space, like hanging them out over an area, as long as we had a way to mount them so they wouldn't move around. Of course, you don't want to drop it, so you don't want to hit anybody. But we can get views that would be awkward at best and unsafe in general for a person to get. Even if they could get a tape measure to it, it wouldn't be convenient or safe. And then we scan from several locations. Provides good scan data coverage. Adequate overlap from scan to scan greatly improves the cloud-to-cloud registration, and it increases the accuracy of measurements over longer distances. This is a very important point, because one of the things we're starting to do more and more of is people have gotten scanners, but they want to have us process the data for them. And so they'll it takes a little training, a little bit of back and forth, but we still struggle with getting them to adequately make sure that the scanner is placed such that the coverage it gets from one to the other, it may get everything they want to see, but it may not include the parts you don't really care about, except for those parts are needed to provide good cloud-to-cloud registration. So it is an iterative process to learn, and hopefully everybody working on this is going to get better and better as it goes along. So if you have had the chance to use Recap, and this is where if I was in a setting where everybody was just in the same room, I asked for a show of hands to see what the experience level is. Recap Register actually has a little wheel that shows how much overlap two scans have, and along with an indicator that says how good the registration alignment was, it also gives you an idea of how trustworthy it is based on the amount of overlap. So it's a critical thing, and really can't be overstressed. So as I mentioned, the thorough coverage not only improves registration, but also provides measurements in areas you may not have known you needed until you've left the ship. So this is where the thoroughness comes in. Very seldom does somebody go out to do a ship check and get everything that they expected, or everything they needed. So they get back and they're looking through their photos and they got their notes and everything, and then somebody says, well, what about this? And it just wasn't in there. And with scanning, the chances of it being there are much higher because you're scanning 360 by 305 degrees. You've got a huge window, and you're taking multiple positions for that. So as I mentioned, kind of alluded to before, more scans and more data is always better than less. Each scan takes between 4 to 8 minutes, depending on the settings and how far you're shooting. If you add color, which I'll give you an example of color in a little bit, that adds a couple minutes. But the Faro scanner does have, the Focus 3D does have an onboard camera. So people often ask about accuracies, and we pretty much go with what the stated accuracy is for the scanner vendors claim. And so within a single scan with most surfaces in the marine industry, scanning accuracy is better than plus or minus 2 millimeters over 25 meters. And when I mentioned the most surfaces in the marine industry, the biggest Achilles heel of 3D laser scanning is highly reflective surfaces. We did a job for Los Alamos National Laboratories where there were quite a few very shiny surfaces, and they also had quite a few painted surfaces. Our accuracy over 200 feet on the painted surfaces was better than the accuracy on a shiny, bright, shiny stainless pipe that was 10 feet from the scanner, because the reflective surface, and this was several years ago, but the reflective surface, it bounced the way it bent the scanner, the signal, it is actually off by 1/8 of an inch, and it was only a 3-inch pipe. Whereas over the 200 feet, we were easily within half an inch, and that was 180 scans cloud-to-cloud registered. So it was very impressive. The scanner's gotten better, so the newest scanner, the X330, the blue one that I showed earlier, we found it to handle reflectivity better. Still an issue, but it's being improved on a consistent basis, and it's just nice to see. Now, when you have multiple scans, you are going to lose something from scan to scan as you register. So we usually say we found our accuracy easily to be 1/4 inch over 100 feet. Assuming good surfaces with good overlap, that is critical. That this is put together properly so that it actually works. So, but also you need to understand the limitations of the scan data so that you don't design your way into a proverbial corner. So you have to be smart about where you place field welds. We really don't do field fit-up welds almost ever anymore. We can make our small adjustments. It may be that you need to do you're a 1/4 degree out of plumb. So instead of specifying a 89.75 degree elbow, you just say, do this one as a field weld, make sure you're in position. And that, just the field weld will adjust for that small amount. So, okay, any questions before I move on to the next topic?
I don't see anything yet.
Okay, well, good. That means I must be thorough. and accurate and safe. I hope I was. So 3D laser scanning for ship piping systems. It was really ship piping systems that got us into this, or piping systems, excuse me, that got us into this industry, or the scanning technology. Because in refineries, which is our background, we're both chemical engineers actually, there's really, I can't remember many jobs I did where it didn't ultimately have to go in a pipe, and that pipe had to be welded. And since most of our work was retrofit, it had to be welded into an existing facility. And when they get there and they find that the design was off because the as-built drawings were off, because that's a lot of money to as-built and it didn't make any money for the refinery, so it wasn't done. Or if it was done, it was done with a tape measure and a plumb bob. It wasn't that correct. All in all, the piping systems had to keep being modified and reworked, and that was very expensive. So 3D laser scanning is a way to resolve that. And so that's how we got into it from a piping standpoint, because every weld and every rework is very expensive. So the kind of the purpose, as I see this, as scope definition, and this is a scan to plan, and we trademarked that this year. The replacing kinda on ships, especially because ships aren't true and square and straight and level. I mean, we found that ships have a lot more piping that is not quite true to the world. And so often when we do our design to replace pipe, we actually will straighten it out, making it more able to be prefabbed in the shop and then sent out to the rig. New equipment installation, process changes, and then of course piping upgrades. So just a change of metallurgy is sometimes needed, and often they see at the end of life to replace some kind of. So,
hey, Darryl, we got a question.
Okay.
Just a quick one. How does your system handle vibrations? Engines from
Yeah.
Also, what about people and machinery moving during a scan?
Okay, so vibration, it's interesting. I've been helping a local ship architect, naval architect firm, get up to speed. They bought a scanner, and they've been going out and scanning jobs on their own. And one of the first ones they wanted to do on their own included, it was a ship that was in transit. And they wanted to shoot the engine room, which of course was in transit and vibrating. So the things you can do when there's it's very difficult if the scanner is vibrating. I've got some scans, like we did a high pressure drill pump room on a drill rig, and on a drill rig there's a lot of time when they're not drilling, and so they're not pumping mud, and that's when you get your opportunity to go in and scan. So we were scanning when one of the pumps came on, and so the scan that happened on, it looked like a spirograph. Literally, it moved around so much that everything was scrolled. So it wasn't usable. So you have to have a stable base, but what you can do is if you can get the scanner further away on a stable base, you can scan something that itself is vibrating, because it may only be vibrating, let's say, plus or minus a millimeter, and the scanner can scan that as long as the scanner itself is not vibrating. We've had pretty good results with scanning under those circumstances. But if the scanner is actually vibrating itself, that doesn't work too well if it's got any length of movement at all. So
on the other hand, we have had situations where the support for the scanner is vibrating to some extent, and we're still able to get usable data. What we might lose is the higher definition of the smaller objects. But overall, the vibration can average out as long as it's not given a net movement of the scanner.
Yeah, so like the high-pressure mud pumps are large reciprocating pumps with a fairly low frequency. So it actually you could actually feel everything moving. I remember specifically a job we did on a compressor station. This was land-based. And the compressor had a very high vibration, very high frequency, and those scans turned out fairly, well, they were usable. They weren't as good, and we put in our disclaimers, but our registrations looked valid for the level of the design. And you just put into your design that you note that. So this is why it's very important that all parties talk. Even if you have somebody else doing the scanning and then they send you the data, it's important that they understand those issues. So it's a very good question. In each case, you let the data tell you how it's doing. So does that answer it?
Just waiting for a response.
Okay.
Yep, it's great answer. Thanks.
Okay, so this is, I'm sorry for the how small this is, but this is actually, it's a scan, it's a screenshot of a scan. And what happened was we went ahead and isolated out a chunk of line, and then we sent this to the client that confirmed that, or actually, we had walked this job with the client. They said where the client was. So before we moved forward with actually modeling in our demo package and our new construction package, we just sent an annotated PDF saying, here's where we think the tie-in should be for our conversation, and this is it. And then they came back and said, yep, that's it. That's what you got. So that's what I call a scan to plan. In other words, we scanned it and then used it for them to plan the work, even though they kind of had an idea of the work. That's just one example. This is the other end of the line, and it was a firewater. It was an upsized firewater system that ran the whole length of the ship, so it's like 600 feet or so. So we just, and it was critical to scan it because they needed to upsize the pipe, and there were places where the previous size wouldn't work, so it had to be designed in prefab so it would fit in, but certain parts of it could not be prefab. And a lot of it was just straight run, so that was easy and did not need prefab. So, but as you see here, tie point to replace, and we're stating the scope and planning the job within the scan data. So now this is just a flat-out scan. This looks like a photo, looks like a negative. But I want at this point to do something I've never done in a webinar, and I'm going to actually bring up a Kerosene software, and just bear with me for a second while I do this. Okay. So we tried this yesterday in our practice run. It seemed to work pretty well. So this is a live scan, a live action shot, a 3D scan, just looking out over the water off the edge of the drill. This is actually a drill ship. And this is
Daryl, I think you just need to move over the larger scan.
Say that again?
I'm only seeing about a quarter of the scan there.
Really? So it's shrunk down?
No, it's moved to the left.
Move to the left? How do I make it?
Oh, there we go.
Is it just that much delay?
Oh, maybe.
Okay, it might be our delay. Now, it would be helpful if a few comments would come in from the attendees just to say, say this doesn't work for some attendees because of their system, but others may be seeing it just fine.
Yeah, there seems to be a lot of people who can see it fine.
Okay, good. So for those who can't see it fine, just buy a scanner and Kerosene, and you'll be able to work it out on your own. So, so this is the drill deck, and the question along with the vibration was, what about machinery moving and people? Well, we scanned we took 5 scans of the drill deck, and for all of these, we basically had we didn't have any interruption in the workers. They were working on some stuff up and down this corridor, and so we didn't have any impact on that. However, when it came time to take this scan, we asked them to go sit back there. So they took a 5-minute break. We scanned, and they were happy. We were happy. We didn't stop progress on the drill ship, and so it worked out nicely for everybody. So I wanted to show you, actually, this right here, this yellow box. I want to show you what you can do in Kerosene if you wanted to take and grab and look at a 3D view, and you can use this. So this is all live, this isn't pre-done. So I'm going to jump to, this is a 3D view of that, the little selection I made. So now you can see that in 3D. So hopefully I'm going slow enough. You can understand exactly what you're seeing. So this is a turret for a crane. So one of the things, especially on drill decks, and we've gotten a few inquiries. Can you use this to do crane reaches and crane studies? And yeah, of course you can. You can turn this into a 3D model, and you can put in your new cranes and all that, and it works pretty slick. So I wanted to, I've got a few different examples, but I also wanted to show you a colorized scan. So I'll give that a little bit of time to show up, but there's a colorized scan of, once again, this is another drill rig. And but here I also want to tell you that you need to understand that even if you're standing where you don't care about the data, like these two guys, they shouldn't be there. For one thing, they're the guys that did the scan. These were sent to us for a job we did for somebody. So they had somebody scan it. Well, if you're scanning, get out of the scans, because even though I may not care about what's going on here, I might want to use this handrail to register to a scan that's done on the other side. And now you're in the handrail, and I can guarantee you, unless you stand perfectly still, you're a real blight on the registration. So that's a little side note. That's one of the reasons I threw this one in here, is a little training needed for the people doing the scanning is get out of the scans. We've actually had to get underneath the scanner. We've been in an area where we had to start the scan, but we couldn't go anywhere, and you had to sit in this little circle under the scanner. Well, sometimes you'll see a little chunk of hard hat or something spitting out, but still, that's better than being scanned. So stay out of the scans. So one more, I'm going to go back now to the scan to plan topic, and I want to say that we've had customers who contacted us.
Hey, Darryl.
Yes.
Just a few questions. What are the green orbs there?
Okay, I think I had mentioned that Faro's registration software uses either targets or spheres for their registration. So these are actually, if I can't remember if I can. I'm at the risk of deleting this. I'm going to delete this. Do you really want to delete? Yes, I do. So now I've deleted what was modeled over that. Now you can actually see what was really there. That's the sphere. So they've got a magnetic holder, and they place it on there, and they basically make sure there's 2 or 3 of them in every scan. Three is really the best number. And so 2 scans that see the same 3 spheres, they can register those together. So this is actually, you can see what the sphere looks like.
And we can note one real benefit of a spherical target is you can get the center of that sphere no matter what direction you are scanning from.
Yeah, it does have some benefits. And the thing is, our first experience with spheres was back in the LS880 days, when it just wasn't good enough, I should say. The improvements in the scanners has made spherical registration much better than it used to be. However, we still find cloud-to-cloud to be an improvement on that. So here you see, I've gone to another one. You still see when it did a spherical fit, and it gets the center point of that. And let's say a scan was taken from over where these guys are standing, and they probably just moved over to the other place, be in that scan too. It'll see this, and so now that center point is known in 2 scans, and that's how it registers. So, and then if I hadn't deleted the model that it developed for this, you would still see the model of the perfect 3D sphere over it. But this is actually what the sphere looks like. Does that answer your question? It's a good question. Very good question. So I'm going to try to move along a little quicker here so I can leave some time for questions and answers at the end. But I want to get this out there. We've had clients contacted us. They definitely wanted to scan, but they were going to scan after they went and did their first ship check. And I said, well, why don't you just let us go out and scan the whole thing, and then give your ship checkers, teach them how to work within the scan data, and then they can do their chip checks. Because a lot of times they want to take lengths and bill of materials and things off of the off the scan. You know, that's what they do. They go out and they measure a pipe and they figure out how long it is. Like in this case, we were looking, this project, they wanted to replace or add something to this line. But let's just say that you wanted to determine how much of this line you had. You can measure within Faro Theme. You can take a measurement. Now you have the measurement of that pipe. Now, notice too that it shows you what's level and plumb. So even though I've got this slightly distorted, the straight line is the yellow, and the blue is your vertical and horizontal. So let me see. Now, once you go into the measuring mode, you start losing the ability to scroll around. So I'm going to take that away, go back up to here, and my center, and I'm not going to do that because it's not behaving for me. Sorry about that. But you can see I can measure it, and for those who are more proficient at Faro Theme, they wouldn't be nearly as embarrassing as I am right now. So I'm going to go back to, so basically what I tell them is, why don't you go ahead and authorize the scanning, because you're going to do it anyway. Do it now, and you can use it during your planning stages. And also you can, let's say that you needed to go out and do a survey. You wanted to get an NDE out there to check UT readings on piping. You could actually now give them precise directions of where you want them to go and measure for thickness within the scan data. So my final slide in the scan to plan part of it, this is scan data that we've then taken a top-down view and slices, and we've created the equivalent of plan views. And in those plan views, you can start notating it and use this as a 2D drawing. One of the big complaints we have, especially with clients who aren't quite up to the 3D world yet, is they're used to working in the 2D world. So this is a very, very cost-effective way to take a scan, slice it, down view it, and get basically a plan view. So, and I finished with this one because my next presentation group of slides deals with this exact piping job. So if you take a look at that, you'll see this again shortly in 3D. So why do we care about laser scanning? We have prefabricated pipe spools, increased bolt depths, reduce field wells, 3D model used during planning and construction, reduce downtime. All of those things save money and make money. So here's another reason. This was a job we did recently that they didn't scan, but they showed us pictures of this job because they scanned the next one. And I noticed right away in the pictures that while they were building it, this cut wasn't there. But what happened was they took all the measurements, they knew where they needed to get to, they're right there doing it, but when it was all said and done, these things were just a little bit too far, so there was an interference down below, so they had to cut this and re-weld it just to put in what probably worked out to be a 0.5 to 1 degree bend in the pipe. So that's just another example of purpose, and a fairly recent one to boot. So here's register scan data. We call it the blob. Once again, visualization is a tough thing to do in scan data, and there are companies like Recap and others who are really working hard to improve the visualization, but it's still a lot of data. Most systems get slowed down. This is our scan data, and then we isolate it. So I mentioned isolations. We can actually, with our software, we dissect the data, and we actually go into it, and we'll create the separate vertex groups that can be brought into AutoCAD or AutoPlant or Plant 3D or whatever your program is, and worked with very efficiently. And the computer systems even 5 years ago could handle the data. Now we can just put in more data, and the systems are able to handle it. You're always limited by what your system can handle and what you can visualize. But now we've actually broken it down into the specific line numbers that match the schematics, the PNIDs. And so each color there is an individual line with its own line number, and this is still just point cloud data. So this is our replacing kind of scope defined, approved by the client. Once they approved it, we went to modeling. So this is the model, CAD model overlaid on the scan data. We're just working with the ones we're replacing, so it's really clean. And then here's back then we were using Bentley AutoPlant. We had tried Plant 3D, but it still wasn't working right for us. It wasn't until 2011, I think, that we switched to Plant 3D. And and then this is your standard Fabrication ISO. So this is ultimately the 2D drawing that everybody cares about. And if you can't make that, then they don't really want to talk to you. So you got to be able to do that. So I want to talk a little bit about feature extraction software. I'm going to put ours at the top of the list, even though we're still not quite ready for prime time. We're using it in-house a lot, and but Qubit is in our experience, it's actually the only software we've ever purchased. We've always liked Qubit. They're great guys over there. Once again, I think this industry has really good and upfront, honest competition, respectful. I can't say enough good things about Qubit because we've actually used it. ClearEdge is another one. I like a lot of the things they do. We've never purchased it. We did a little beta testing, but it was years back. In fact, I think they might be having a webinar right now on ClearEdge structure, which is a big deal. And both Qubit and ClearEdge are probably leading the pack on that as far as your standard feature extraction. CloudWorks, we've really not done much with that, but it is out there. Polyworks and Geomagic, just some different companies that provide feature extraction software. And the number's growing, and even now, all these years into it, software is still the biggest need in this emerging technology. Faro has definitely stepped to the plate to provide a cost-effective scanner that really has beautiful data. So that is a wonderful thing to see. So I'm going to now jump to a quick video. So this is our software, and I'm just going to show you a quick clip of this. I think we're getting close to being out of time, so if anybody wants to tell me that you want to stop the presentation roughly 10 minutes ahead of the end time to take any more questions, or we just keep, you got a question, this is a good time to do it. This is somewhat self-explanatory on the video. We have, this is just different colors or different scans. So you see we have great coverage of this. This is the aft pump room, forward pump room. This is a forward pump room on a ship. And actually, a lot more space here than we usually get on a ship, lots of open space, but we did scan under the grating as well. So now we go to a volume box. I mentioned that working with scan data in large volumes just slows down your system, so a volume box is a fairly common thing to do. Because we're not at this point ready to sell our isolation capability, this video clip is only showing our cylinder fit pipe fitting application. So there you find the pipe, all the data is there, but your volume box has allowed you to get down into the area you want to work in. And it's a manually driven. ClearEdge is a little more automated. Both ours, Cohera 3D and Qubit, are more manually driven, and it's a preference. I think both are viable, but we don't sell that anybody can just do this. You really want somebody who's involved in design and understands what the end goal is to be involved in this work. So manually directed is still important to us. So here's two lines came together. So ultimately what we're going to get out of this are polylines. So every cylinder has a center line. So these are perfect cylinders based on the data. They find a center line. So now we are pulling those polylines or center lines and importing those into Autodesk Plant 3D. This is where you move from just a 3D model to a smart model, one that you can use for bill of materials, and the new catchword is BIM, Building Information Modeling, so or management actually. But the idea is that each piece is smart and has information you can use to purchase it. So you need to tell it, our cylinder fit tells us it's a 6-inch pipe, but you need to know what the pipe spec is, if it's going to be a Schedule 80 or Schedule 40. But once you know all that, you can just tell it, go ahead and make this. And so this is all live in Plant, or not live, this is a video made in Plant 3D on top of the scan data that the original cylinder fits and polyline center lines were created in our Cohera. So back to our presentation. You see, that's not what we wanted. Are we up? Okay. So I think we're out of time. I'm just going to go through these real quick. We have more piping examples, and pretty much the same thing we had before. So I don't really see. This is just this is all the data. There's a blob. It's just scan data you see that's been isolated out so you can get a feel of the routing. This is actually the drill deck that I showed in Ferrocene that we scanned for the purpose of replacing and upsizing the high-pressure mud drilling site. So this is just scan data. This is modeled on top of it. This is just the model, and we replaced in kind. So back to what we've done before. So I have one more slide I want to get to, and if I can pull this off, let's see how this works. It's a not quite subliminal message. Oh well, I didn't get there. Yeah, there we go. How's that? Is that a good way to? If there's no more questions, I do have a couple videos I want to show. So if there's a question, I'll take that.
Yeah, we have a few questions, Daryl.
Okay, let's go for some questions with the last few minutes.
Okay. Can you walk through the ship using multiple scans?
Yes, you bet.
Okay. Prior to measuring, is there any calibrating involved, XYZ data inputs?
Well, the scanner, the scanner is calibrated by the shop, by Faro, and so it comes decalibrated. The only thing that we've done in the field is the scanner basically does a 180 plus a few degrees overlap turn, and so it combines those two because it's basically doing a plane. So at that seam, we call it, there's a compensation factor that can be applied, and that's how it can be fine-tuned after some amount of time where it might have drifted. But there's not a calibration per se that you do. We do check it occasionally against. We have our own system in our home office where we can test it and see how it's doing, and that's pretty common. The other thing is you can use your registration to evaluate how good the accuracy is just like with survey, you check the closure of the data. So, but no, there's not a specific calibration for the Faro scanners that are done in the field.
Great, thanks. We have another question. When you isolate one pipe system, do you mark the pipe before scan, or must it be done later?
Well, it's all done in the scan data, so we don't do anything to systems. We may put up a note or something on a pipe, but no, it's all done in the software. It's not pre-marked in the field.
And when are these scans completed? While ships are in the shipyard, or when they are moored, and does the ship have to be free of cargo?
Well, you just have to be able to see what you want to get. You have to be able to see what you want, what you care about. So, for example, most of the examples I gave today were on ships that were active. I think the one colorized one, that was in the shipyard for some standard maintenance, and then they wanted to add a piece of equipment to it. So, in fact, it was scanned in the shipyard, but the equipment was actually added when it went back out in the field. So, it's just whatever the timing allows, and
Okay, thanks. What is your take on combining short-range handheld scanning capability with the Faro Focus 3D?
We thought about it because we can scan like up a tower. We haven't done it. We almost did it with trying with photogrammetry, but ultimately what we ended up doing, because there was something that was out of sight on a platform on a distillation tower, and so what we were going to do is try to take a photogrammetry, but to get the location of one piece that was shielded from the ground. So ultimately, all we did is just measured down from it and noted it, and so what we measured from as a reference point, we knew and just noted that in our data. But I think that would work just fine.
Yeah, we just need to make sure there's a reasonable way to register the data between the two sources, which should be possible if there's sufficient overlap.
Yeah, and with the E57 as a new standard that's been taken on by everybody in this field, no matter what your scanner is, it can get the data into E57 format, and then that can be brought into any of the registration programs that I know of.
Okay, thank you. And one more question. How do the scanners and data react to bright sunlight?
The newest scanner, the X330, that one, the one that I'm telling you to go out and buy, that one has it's eye safe and it handles direct sunlight just fine. The scanner I bought in 2010, it has a little bit of a problem with bright sunlight because sunlight wavelengths interfere with the wavelength from the scanner. So I think the technology is getting to the point where it's better in the bright sunlight than it was. That's certainly what we found with this scanner. So I'm going to take the subliminal message off again. I just want to say real quick, with 3D laser scanning, you can be confident in your installation even with tight tolerances. The example I have up here, I'm not going to show the video, but I've got a call out, local refinery. The contractor said we have to take the pedestals, the existing pedestals, and grind them down. Probably would have cost 15 to 20 grand. And the project manager called me up and says, can you come out and scan this and tell me if he's right or not? I said, of course we can. Well, we went out and we scanned it, 4 scans, processed the data, and by the next morning we were able to tell them, you have a ½ an inch to spare. Well, the issue is, it wasn't that they couldn't measure, it's that they didn't feel confident in measuring to within a ½ an inch and then being able, because they couldn't take this thing in and out. The rigging and everything to move this reactor was kind of a one-way deal, so they really had to be correct. And so we gave them the confidence to go ahead and do that. And, you know, I think our cost to them was a couple $1,000 and they easily saved 20 to 30,000 from what they were planning to do. So you can be real confident that your installation will work. If it works in the scan data, it's going to work in the real world, as long as all the pieces are together. Now, in this case, we scanned what was built along with where it had to go. So we had all the pieces right there. Sometimes you have the parts you need to put in, they're somewhere else. You can either go scan them or you can trust that they were fabricated correctly. We've done a few jobs where we've actually scanned something fabricated to confirm that it met the design. Okay?
Great, thanks. We have one more question. What software is best to do the walls and the floors? Revit, CAD, or Rhino?
Well, for walls and floors, we're using Revit. Our YouTube channel is Summit 3D, just one word, and we have a couple examples, I think, of architectural work, and walls and floors. All of that we've done in Revit.
Great, thank you.
We use Rhino for the whole, so we also have examples of that.
Okay. Well, thank you very much, Daryl. I appreciate it. On behalf of the Maritime Reporter, we have a few more questions, but I just want to thank everyone for attending. And at the end, when you log out, there's just 5 quick multiple-choice questions we ask that you would take. So thank you very much.
All right.
So, Daryl, just 2 more questions.
Okay, that's fine.
What was the software used to isolate the piping polylines? Bentley AutoPipe?
No, that was our software. That was Summit's proprietary software. We're calling it Cohera 3D. The isolation software is not something we're planning to sell. We use that in-house. The actual modeling software, Cohera 3D CFA, pipe fitting application. It's not on the market yet, but we're getting closer.
And can the scanner be configured to record data points only within a desired radius, or does it have to measure everything within its field of view?
No, you can set a column of data. So yeah, you can say I only want to do from 20 degrees to 40 degrees, and it's fairly easy to do.
But in terms of distance, it gets everything, but you can trim the data after the scanning is done to limit it to some specified distance.
Right.
Great. And can you just repeat the YouTube again for everyone?
It's just Summit 3D. If you just go to YouTube and type in Summit 3D, SUMMIT, the number 3 and D, that's our YouTube channel.
Great. Thanks very much, everyone. I think that's it. That's all our questions.
All right. Well, that's super. Good timing.
Perfect. Well, thanks, Daryl. Thanks, Norm. Appreciate it. We, on behalf of Maritime Reporter, thank you again for presenting with us.
Well, thank you for having us. We appreciate it.
Okay. Thanks, everyone. Bye-bye.